Welcome to Wickerson Studios. My name is Michael Wickerson, and I am starting another series here that I'm actually calling Fun with Functions in Grasshopper. And I started it earlier this week, and I put out the initial video, which was this first script, but I thought I might overview what I'm interested in doing, and I'm doing this before going into classes. I think this is for Grasshopper fans that want to learn Python and what that means. But I also want to learn Python while I'm in the Grasshopper canvas and in the Rhino 3D environment. So as we build geometries, we can kind of visualize what the functions are doing. And for the visual artist and designer, possibly architect, I think that's very important. It's certainly important to me. There's some great video series online. So I follow, I think, what are the best people out there, but I don't do what they do. I do what I want to do. I do what I think gains the most learning on my part or at the pace of what I want to learn. So what I do is I bring an awful lot of things in under Wickerson Studio user objects, and I have millions of them here, but I've started this new series, and there's only 3. They're pretty simple. They're basic, and it's going to be defining a function, passing arguments, and default values. I spelled that wrong, default values, which is fine. I make these available on my Patreon for a little while. And then you can get access to my private GitHub sites. But then usually within a couple of weeks or a month, I make those sites, those GitHub files public because I want to see what people do with them. So instead of going into a Python book, let's say the book Python Crash Course, and starting at the beginning and having to go through types and loops and for loops and all this stuff, let's apply it. Let's jump into chapter 8. Let's jump right into what's covered when looking at functions. Because what is a function? And that's what I want you to start writing in your Python script. So I'm going to shut this one down. This is a geometry that's created on this second set, and you'll see that I set things up to be progressive. I've only covered in here functions, defining a function, passing information to a function, arguments and parameters, what's the difference between those, what is required and what has to be filled, passing arguments all the way down to default values. So these 3 scripts cover about to there, and I leave out some things that are irrelevant. What's interesting is I'm taking the data that's coming out of the text that is string-based and word-based, and I bring it into numbers, and then with that data, you can see I'll export it and bring it in as numbers, and I'll drive some type of creative Wickerson Studio geometries. I like to add a P in geometries for some reason. I'm not sure why I do that. Maybe it's just my fingers click it. Let's just repair that, and then this would be saved as the 3 default file. That would be available as a GH script, but in here, what I have nested in here, if I run this one, and take this and put this to actually, you can run all the scripts, which isn't bad. Enable all the scripts up to this point because you're not doing anything with the data. What's probably key is that as you enable these, you probably want to leave off the geometries and not mess with them, because what I do in my geometry examples, and you can see how this one's just running, and it takes a little while to process because there's so much activity going on in it, and I just activated this top one. It'll think that I want to crash out, but I'll just have to be patient with that. So the files are a little slow when you have the geometries open, but I'm really just driving data. And what I've done is I've chased my solids back to surfaces, back to lines, back to points, back to point attributes, and back to the data driving those point attributes on a kind of an XYZ level, building points and building vectors. So that will start to make a little sense as we dig into this. Might have to hit. Good. All right. Just getting back into it. But basically, I want to cover after I get through these examples 1, 2, 3, kind of picking and choosing what I want here, dealing with return values instead of just print lines, because I actually want to get into the data. These are user objects that are Wickerson Studio user objects, which are downloadable as well. And within them, because they're not compiled, you can see what's going on in there. The first one I showed on my initial video is pretty simple. I wanted to take single information 3, run it through a list Y, and through a tree of data Z, and see how that would process. So that script itself, as we go into it, what I'm going to do for right now is I'm going to take off what's slowing down these scripts, and it literally is turning things into a single brep. So I'm just going to disable that, and now things should move a little faster throughout my geometries as I go. I'm going to take these, leave those ones off, but I'll take these ones, and I'll put these ones all in enable. I think they'll move pretty quick. So we can look at a couple of different geometries as we go. And as for what is there, we'll make this one preview on. And I think what I'll do is make this one preview on as well. So then when we look back at the Rhino environment, we'll see what kind of geometries are happening here. But as for the scripts, it's pretty interesting. You go in here, and I'm writing basically out of the text what you have to think about. And I'm trying to jazz it up and take it from strings and put it into numbers. So this one I've covered before. It's pretty dead simple. You can see its output coming to the output, which I then bring into ABC in different forms as a single item, a list, and a tree of data. And that's pretty straightforward, but you're learning how to write a function number. You're learning how to write a function numbers, and you're learning how to write a function list numbers, which basically creates a single number, creates a list of numbers, and creates a list of numbers. Now, it's kind of a redundant function because you can basically pull all this data directly out of your inputs that are going into it, but you wouldn't be writing a function. You'd be letting the computer do that on your own, and I think it's just interesting to have a way into that. Now, the geometries, as I close that out, is an interesting geometry here. If I focus on this one, you'll see it's a smaller one tucked in there because it's driven by this data, and that is visualizing through the way I think of sculpture. And what I'll do is I'll take numerical data, I'll put it through points as we go, and vectors, which are invisible unless you make a visualization on the vector. I'll put it through a simple curve geometry. I might do some lofting the surfaces. I'll turn those into solids. I'll do a little bit of transportation manipulation, and then I'll always put things back into a single breath. But I'm leaving that off because that's when things slow down in Grasshopper. And I would encourage anybody who gets to this point and understands what's happening in their transformations and what they've basically done, be it whatever profession they have. I'm going to keep my geometries dead simple, so we're really thinking of computational design as opposed to kind of a static modeling in Rhino. But you can pull this one back in as a bake, avoid the weight on these long things, bake this into your form right here. I'll have to leave to get that to bake, I believe. Bake it in, and then with this one, they're all separate. You could grab all of those instances of those water type forms and do your Boolean union in Rhino, which so many people are accustomed to because they learned static modeling first. So this video is going to be a little long, but that one's said and done. If we go down here and leave that one up, I've written another script that's considering, okay, what does it mean to pass arguments to a function? This is very similar, giving us the same outcome, but I want to show you the script, how it changed. And how it changed, I've got to pull it down from my other screen. You'll see that it's basically the same, but you're thinking of your function as to what's possible. So in the initial one, creating a number, I didn't leave it empty. I actually set it so I could set data to it. So it runs exactly the same, but instead of running it as this being blank and calling whatever it ends up calling, you'll see the difference in that function if I bring up the other one, how I wrote it. The first one being here, you'll see how that data was, you did not put in any arguments required. So the parameters didn't have to be set, but it still ran the data. This one is being very specific to say, okay, I have an argument, and then I'm filling it, parameters, and I'm filling it with those arguments. So think of it that way, and you can distinguish and kind of get your head around what it means to what a function requires and what it does with that when it's put in there, and then what is the output. And we're actually getting down to returning something here as opposed to just the print. It gets farther into what I wanted to cover. I did the same thing with the list with Y, and I did the same thing with the Z, which would become a tree of data as well. So it ran the same, and I thought that was pretty interesting. So you can get your head around this, look into these files, and then I didn't drive a geometry through the second one because it would just be the exact same geometry as the first one. So let's close that out, and we're thinking about that's the big geometry, and this was the small one we just generated here. And then, as I go through and want to learn more, because we're going to cover everything in here. We're going to run through default values, return values, passing a list. We're going to get into, there's a couple of typos in here I have to fix, but get into making your own modules and running them. This will be for the visual artist to start to try and see the data being driven in the physical form. That's really why I'm making this. So we'll leave this. I'll probably take this one to preview disable. And then, actually, I probably don't want it on disable. We'll do enable, but we'll just take the form, and I think because I disabled it, it'd have to run the script again. You can kind of be careful with these functions. I'll just leave it disabled. The last one is getting in and saying, how do we set default values? So I'm going to open up this script, and you can see how this one runs. And it wants to be very similar, and I think you'll get your head around it, because I'm getting my head around it. And believe me, I'm a little slow at this stuff because I'm learning it as I go and returning to it. So let's look at that number. I've set a default in here. A will be 2 unless I indicate what A is. So I think this is pretty interesting if you think about it. That's going to drive data. If I change this, and the geometry is going to run pretty quick, and you can see the visualization of it as well. If I didn't indicate an X value and import that and left it blank, if I didn't indicate the Y value of the list, it would then interpret it as 1, 2, 3, and A is 2, and B would be a list of 1, 2, 3. So if I run that, you don't really see what happens. You see the data changing, but what's nice is you can see the geometry changing. So that's your default script. It will always come back to that, so somebody has something to visualize and look at. And then if I want to import in what I put into my inputs on my Python node, X and Y, and you can extend this to Z as well, you can see that that's the default, which is actually parametric. So I can get in here and I can roll that back, and you'll see that that changes. Pretty simple design. But if I don't want it to be parametric, I can default it by a default value to hard coding it by just leaving out that data and Xing that out. So the script is something that you want to watch the video along with, test it, and there's your default script right there. Which actually, I like the default better than the other one. And you can play with geometries. But once again, I'm going to leave it in there and let it be optional. It's not in the script, but possibly what I'll do is I'll take this and I'll copy it and I'll put it down here. I didn't mess with the tree data because that's a little different. I'm going to leave that default there. I'm going to take this one and copy it. Actually, I'll copy just the line. I'll put it in here, and I will just hashtag that out. So as you can do, you can comment out these other ones as you go. And what's nice is you can play with it as that's going to be the value. But if you wanted to bring that one alive, you'd hashtag out the top one. So you're literally just making your decisions of hard-coded or parametric model, which is what you want to do. And this is making things much more intelligible to me. I can understand them a little more. And of course, I forgot to X out the X because it kept it. So if I take off the X and run it, it's going to go back to that form that I liked. So you can play around with that, use your data to drive it, understand functions. I think it's a great example to start. And as we go into it and we make things, like I said, be careful on my scripts when you start to really see the profiler. What I would recommend is on displays going down the Canvas widgets and always keeping your profiler on. And anything that gets above 1 millisecond, you probably want to hesitate to run. But I think it's nice because if I do run it, it's going to take a little bit of time. Then I can see my naked edges afterwards. I can do some other things with it, piping, and I can make some pretty interesting forms. But I want people to realize how the power of Grasshopper, if you take things back from the solids through the surfaces, the curves, the points, the numerical data, and how do you drive that data? And you're driving that data by learning how to script, be it GH Python, or if you want to do this in C, you can do that as well. These scripts are easily to translate back and forth each one and learn a basic language. So as we go back into it, we've done the default values, and I probably need to spell things a little better. I'll correct my spelling before I put this out, probably, or maybe not. Let's just slide in a T there. And then what I'm going to do is I've talked about return values because I've used them because I want the data coming out instead of the out function. I want it coming out of A, B, and C, or whatever my outputs are, A out, B out, C out. And we're going to go into passing a list after this, but right now we're going to do kind of a conditional function loop on data, which is going to build a whole other geometry that will have control through our ghPython node custom, you can call it a custom user object, which is what I'm using. I'll make one with while loop, and then you can actually have more interface and more power over it. And this is for people that, like the vanilla Grasshopper that's provided for you, but want to start thinking a little more like me, to say the least. And that's to get in here and to say, there's a lot of objects that are not on the plugins. And even if they are, I don't have access because they're compiled, but I have tons of things that I want to have control over. I'm not much of an icon builder, but you can see that I definitely am a user object builder. And I think I've used everything from even Unity through Unichiro Horikawa, out of Warsaw, out of Raya Isa. This is how I think. And once we're done this chapter, which is fairly fast moving, and if you need the visualization to learn Python and learn how to work computationally, then I think this series will be helpful to you, even if you don't like my videos and they're chaotic and I'm kind of talking through them, but just to have the files in front of you and have those nodes up and running that you can see the basic ones, the intermediate ones. We'll do an intermediate under classes, and we'll just see where this chapter goes. I think we're going to move from classes through to files and expressions, and then testing code and figuring out, making more and more, and hopefully get into algorithms. And then I'll return to that ghPython book Chinese text on algorithm and computational design. So I hope this makes sense. I hope you enjoy it. I know I'm enjoying it, and I'm still following a lot of great people online. They inspire me, they motivate me, they're clear, they're concise, they're cogent, they're intelligible, and those are all things that I suffer with because I just like to learn while I talk, and I think there's got to be a certain type of spontaneity and off the cuff about people to make life interesting and fruitful. Thanks very much for watching. Michael Wickerson, Wickerson Studios on Patreon, files on GitHub. Sign up, support me if you like, or just sign up and play around with it and show me what you're doing. Thanks for watching.